So another example of creating an equation based on some data. Matt buys t-shirts for the company that prints on them and resells them. When he buys the t-shirts, obviously the bigger the order, the more cost in total, but the bigger the order, the smaller the cost per shirt. So you can see 500 shirts cost $3.25 each, 700 shirts cost $1.95 each, and so on. Matt, what he wants to do is he wants to get the price of his order down to below $1.50 per shirt. So he has to figure out what size of order he needs to place. Well, we can use the equation of this data to determine that for Matt. So we'll go over to the calculator. I've reset mine and I've turned diagnostics on. Make sure if you do reset it that you do turn diagnostics on each time. But to get into the list editor, we press Stat and Edit. Highlight List 1. Again, if you have a handheld, it will be highlighted automatically. If you have data in here, I'm just going to put some random data in. If you have data and you want to clear out the whole column at once, go up and highlight the list name, then press Clear, and Enter will actually clear out the entire column at once without having to do it item by item. Anyway, we're going to input the number of shirts in our first list. And the cost per shirt in the second list. Quit out of the list editor, go second mode. Back to Stat. Now we're going to the Calculate menu. We want linear regression, option 5 on mine. Enter to actually complete it. And we get that the equation of this, I'm not going to write out the generic one, just going to write it with everything filled in. Y equals negative 0.0065x plus 6.5. Question B is asking us to interpret some pieces of this equation. Now, the slope of a linear function is the leading coefficient. That is negative 0.0065. This is the change in the cost per shirt. And because it's negative, this means the more shirts Matt orders, the lower the cost per shirt will be. The y-intercept of 6.5, this would be the cost if Matt ordered no shirts. We could also call it, this is the flat cost. So the company charges him $6.50 no matter what if he orders one shirt or 5,000. Question C, use the function to extrapolate the size of the order necessary to achieve the price of $1.50 per shirt. Now, unlike the last example, we will not be plugging $1.50 in for X. We'll actually be plugging it in for Y, because I've given you the cost, which was our second list. When we create the equation, that becomes our Y value, so we'll plug it in. I'll plug it in as 1.5. equals negative 0.0065x plus 6.5. Subtract 6.5 from both sides because we're trying to solve for x. So we get negative 5 equals negative 0.0065x. Divide both sides by negative 0.0065. And what we get is that x equals 769.2. We need to think about this a little bit. If this was just standard math, we would round it down to 769. But because of the situation where the more shirts he orders, the less it costs, if he doesn't hit $1.50 per shirt until 769.2 shirts. Means if he orders 769, he hasn't got the cost all the way down to $1.50. It won't be $1.51, but it'll be $1.50 point something. So he would need to order 770 shirts to get below $1.50.